Welcome back. Here in this lecture we'll talk about how to examine DTFS again from a linear algebra perspective. In the previous example we have used this notation where the columns of B's are the columns B0, B1 until Bn-1, where each of these columns represents the complex exponential of different harmonics. B0 has a 0 harmonic, it's a DC. B1 is a 1 cycle using n samples to rotate anti-clockwise in 1 cycle. B2 using n samples to rotate anti-clockwise by 2 cycles, and so on. Now we'll change the notation a bit. We'll call B as W bar later on, because W is actually the DFT matrix. So W bar and W are related. W bar tells us that it's the conjugate of complex conjugate of the matrix W. Now we know that W and B are square, so this is a square matrix. It has n rows and n columns, and its columns are independent. Therefore this square matrix is invertible, therefore implying that W minus 1 exists, or in this case W bar minus 1 exists. So now it is very clear. How do we get C? Simply multiply W bar by X is equals, W bar minus 1, the inverse of W bar is equals to W bar minus 1 W bar C. This becomes identity, and therefore C is equals to this equation over here. You will realize that the inverse of W bar is equals to Wx with a scaling constant of 1 over n later on. Alright, so you go through the math, and this is what we are trying to prove. We're trying to show you that because B has orthogonal columns, therefore the inverse exists, and it is very easy to calculate the inverse, and the 1 over n comes out because the columns of B's are not orthonormal. The details of what I have just spoken are listed here. Please go through it by yourself. The key idea is that the inverse of W bar is this equation over here, and because W bar is a symmetric matrix, therefore the conjugate disappears when we apply Hermitian transpose, and the 1 over n is there because the columns of W bar is not normal. So read this, and this is the explanation of why the inverse of W bar is 1 over n multiplied by W. I also give you some examples, real examples, where I generate for n equals to 4. So I would have W bar as a 4 by 4 matrix. So this is column B0, B1, B2 and B3. This is W bar. And then I want to find the inverse, W bar inverse, and these are the columns, and if you compare the columns, the value is different to W bar by 1 over n, and in this case n is 4. The second difference is that if you note carefully at B1 and this guy, you will see that the faces are rotating on the top. This is rotating at anti-clockwise, or this is rotating at clockwise direction. So the inverse of W bar is scaled by 1 over n, and the faces are rotating in the opposite direction. I also generated the DFT matrix, which is called W, and now it is obvious that W and the inverse W are almost equivalent, except with a scaling factor of 1 over 4. So it's 1 over 4 times W equals to the inverse of W. So this is what we have found. So the last line I would like to highlight is that W is almost a unitary matrix. It has orthogonal columns. Its inverse is the transpose of itself, and because the columns are not norm of 1, we have to introduce a scaling factor of 1 over n. We again see the picture next, where W is the DFT matrix. 1 over n comes out to scale the columns to make them scaled properly, so that when they multiply with W bar, 1 over n W times W bar will be the identity. Now let us examine the columns of this W and see the rotation. Notice that the first column again is all 1 because it's the DC. The second column, which we call it B1 in the past, is also rotating, but this time he's rotating in the clockwise manner as opposed to the synthesis matrix, which rotates on the anti-clockwise manner. So this is rotating in the clockwise manner, but W bar is rotating in the anti-clockwise manner. Again, we are using the fundamental frequency as 2 pi divided by 8. That means we take 8 samples to rotate 1 complete cycle. So this actually is the summary of the synthesis and the analysis equation. The relationship between W bar and W, a complex conjugate of each other. The 1 over n is introduced such that 1n W times W bar is identity. This is the analysis equation. Ck equals to 1 over n xn times this. So this term can be expanded into columns of W, which will be these columns of W here, and it will show that it is columns of vectors, complex exponential, rotating in the clockwise direction. W is the well-known DFT matrix. So finally, we summarize again. The synthesis equation looks like this: x equals to W bar C. The analysis equation looks like this: 1 over n W times x equals to C. We now interpret analysis and synthesis as matrix transformation on the vector C as well as the vector x. Thank you.